we have this question from our exercise on change of variables in partial derivatives. Z is equal to x to the fourth minus 2x squared y squared. So here Z is a function of x and y. But x and y are functions themselves. X is equal to v plus 2t and y is equal to v minus 2t. You're to find the partial derivative of z and t. Okay, so I see that x is a function. You have y is a function. We're supposed to find the partial of z and t. We have our x, y, z, and t here. But what about the v? Well, it seems as if v is just a constant, right? It is a number. So let's work it out and see how it goes. Now, the formula that you're supposed to remember: a change in z is equal to the rate at which z changes as x changes times a change in x plus the rate at which z changes as y changes times the change in y. Alright? Now, here, this can be related to various situations as we've seen before. Now, let me make z change with respect to time. So we divide by a change in time, we divide this by a change in time, and we divide this by a change in time. Now here, the limit as the change in time gets smaller and smaller and tends to 0. Within that limit, then all of these del, which means change, becomes delta, which means derivative. So partial derivative of z with respect to time is equal to the partial derivative of z with respect to x times the partial derivative of x with respect to, well, t. I said time. Usually it is representing time, but we were not told that in this question, so let's keep it as t. Alright? And this plus partial derivative of z with respect to y, or you put a dot there to show multiply, times the partial derivative of y with respect to t. So we find each. We need to find the partial derivative of z with respect to x. We need to find the partial. Sometimes the word derivative is left out, so you say the partial of x with respect to t. We need to find the partial of z with respect to y. Sometimes it's written partial z by partial y, right? Just like we say dy by dx. And here, we need to find the partial of y with respect to t. Partial y by partial t. So we need to find all four of them. So, let's see how it goes. Partial of z with respect to x. This is what I'm seeing here. We have 4x cubed. So we're going to have a 4x cubed minus 2 times 2 is 4. So it's minus 4xy squared. Minus 4xy squared. Alright. Partial of x with respect to t. What is that? Well, this will be 2. And to consider v as a constant, alright? So this is going to be just 2. So partial of x with respect to t is 2. What about the partial of z with respect to y? Well, this x, it will be constant, and then we have 2 by 2, so it's negative 2 2 4, negative 4x squared y. It's negative 4x squared y minus 4x squared y. Then the partial of y with respect to t is going to be negative 2. Alright? So this is negative 2. Alright, so we put them together now. Delta z by delta t. Partial of z with respect to t is equal to going to be delta z by delta x times delta x by delta t. So you have 4x cubed minus, well, 4x cubed minus 4xy squared. So it's 4x cubed minus 4xy squared times 2 plus, okay, so plus, and we have it here, negative 4x squared y multiplied by, and then delta y by delta t is negative 2. So, just putting it together now, the partial of z with respect to t is 2 fours 8 x cubed minus 2 fours 8 x y squared, negative and negative, the minus to give you a positive, so this is plus 2 fours 8 x squared y. Now of course you can do some factorizing. Delta z by delta t is equal to, put 8 outside the bracket, and x is a common factor as well, so this would be inside the bracket x squared minus y squared plus x y. Alright, so that's what we have.